In this video, we'll look at strategies for evaluating integrals of the form sine to the mx times cosine to the nx dx. Part A. If the power of cosine is odd, we will save one cosine factor and use the Pythagorean identity cosine squared x equals 1 minus sine squared x to express the remaining factors in terms of sine. We can then use a u substitution where u is sine x. Part B. If the power of sine is odd, we'll save one sine factor and use the identity to express the remaining factors in terms of cosine. Again, we will use a u substitution. This time, u is cosine x. Note that if both powers of cosine and sine are odd, either method A or B can be used. If the powers of both sine and cosine are even, we can use the half angle identities. Sometimes it'll be helpful to use this identity, sine x cosine x equals 1/2 sine of 2x. In the first example, recognize that sine has an odd power. So let's start by factoring out sine x. We'll pull out 1 sine x. That means we're left with sine squared x, and cosine squared x is still there as well. We can use the fact that sine squared x is 1 minus cosine squared. That's your Pythagorean identity. So we now have sine x, replace sine squared with 1 minus cosine squared x, and then cosine squared x, we'll just pull that down and drop down dx. At this point, we'll make a u substitution. Let's let u be cosine x. Then du is negative sine x dx. Recognize that we don't see negative sine x in the expression, but we do see sine x. Let's divide both sides by -1 so that we can make negative du sine x dx. Now going back to the integral, we have the integral of 1 minus cosine squared, which we are now calling u squared, times cosine squared, that is u squared, and then the sine x dx is here. We're calling it negative du. So we'll have du on the right, and let's pull the negative out front since it's just a constant. From here, we can do a little bit of algebra. Let's distribute that u squared. We have u squared minus u to the 4th du. Now we'll integrate. The integral of u squared is 1/3 u cubed minus, then we get 1/5 u to the 5th. All of this is plus c. Let's then distribute the negative sign. And finally, we'll resubstitute. U is, as we said earlier, cosine x. So we now have negative 1/3 cosine cubed x plus 1/5 cosine to the 5th x plus c. In our next example, recognize that cosine is the odd degree. So we'll start by factoring out 1 power of cosine. We're still left with cosine squared, t over 2, and we have sine squared, t over 2. Next, we'll use the Pythagorean identity to rewrite that cosine squared in terms of sine. So we can replace cosine squared with 1 minus sine squared t divided by 2, and bring down the sine squared t over 2 dt. From here we can make the u substitution. Let's let u be sine of t divided by 2. Then du will be 1/2 cosine t over 2. Notice that the 1/2 does not appear in the integral that we have, so let's multiply both sides by 2. We'll now have 2 du equals cosine of t over 2. Now making the actual substitution, we have 1 minus sine squared, we are replacing with u squared. And again, sine squared, we are replacing with u squared. The cosine dt is now 2 times du. So we'll put du at the end, and we can pull the 2 out front since it's just a constant. Simplifying from here, we can distribute that u squared. We have u squared minus u to the 4th du. Then integrating, we'll get 1/3 u cubed minus 1/5 u to the 5th. All of that is plus c. Let's distribute the 2, and at the same time let's go ahead and plug in our u substitution. U, we said, was sine of t divided by 2. So we'll have 2/3, replace u with sine of t over 2, and that is cubed, minus, distribute the 2, we'll get 2/5, replace u with sine, that's sine to the 5th, t divided by 2, and plus c. In this example, both cosine and sine are odd, so we have options. We can use either method. Recognize this time we also have a definite integral, 0 to pi halves. I'm going to choose to make the sine the part that I tweak. So we'll pull out a factor of sine, and now we can rewrite that. We'll keep cosine as it is. Sine to the 4th x. We're going to use the Pythagorean identity to rewrite that part. Sine squared x is 1 minus cosine squared. And since we actually have a 4th degree, that factor is occurring 2 times. So we'll square that quantity. From here, we'll make the u substitution. Let's let u be cosine x. Then du is negative sine x dx. Again, we'll need to divide by -1 since negative sign doesn't occur in the integral. Now rewriting this, cosine, remember, is u. So we have u to the 9th times 1 minus u squared, quantity squared, and then the sine x dx is our new du. And we need to make sure we pull that negative out front. Recognize that we did a u substitution, and since we're dealing with a definite integral, we need to change our limits of integration. The lower limit initially was 0, but now we're in terms of u, so let's plug in 0 here. Cosine of 0 is 1. And then the upper limit was pi halves. Cosine of pi halves is 0. So our new upper limit is 0. At this point, it may look a little weird because our lower limit is bigger than the upper limit. We can change that. We can flip the limits of integration by changing the sign of the integral. That's going to be helpful for two reasons. It'll flip the limits and it will get rid of our negative sign. So we have now the integral from 0 to 1 of u to the 9th times 1 minus u squared, quantity squared, du. Let's do a little bit of algebra now to clean this up. We're squaring a binomial, so we need to square the first, that's just 1, double the product, that will give us minus 2u squared, then square the last term, that will give us plus u to the 4th. Still du. Next, we can distribute. We'll get u to the 9th minus 2 u to the 11th plus u to the 13th du. Next, we'll integrate. We'll get 1/10 u to the 10th minus 2 divided by 12 is 1/6 u to the 12th plus 1/14 u to the 14th. And we are integrating all of this from 0 to 1. Plugging in 1, we'll get 1/10 minus 1/6 plus 1/14. And then we have to subtract. Plug in 0, we'll just get a bunch of zeros. Really no need to show that. And finally, simplifying this, we get 1 divided by 2/10.